Anthropic just released a major labor market report. It contains a chart showing the gap between what AI could theoretically do across every occupation and what it's actually doing. And that gap is, well, pretty big. I think the chart is a very honest picture of where things stand with AI today. Studies have found that AI could theoretically handle 94% of tasks in computing and math. It's doing 36%. In legal work, apparently it can handle 90%. It's doing 20%. In most categories, the gap is even wider. Today I'm going to cover what is really slowing this down and why this ceiling may be just too high to start with, and what technology leaps we must make for AI agents to truly impact 93 and 94% of tasks across different jobs. This is In the Loop with Jack Horton. I hope you enjoy the show. So let's start from the top. I think there's a couple of stories from this really interesting study, but most importantly, the chart. So Anthropic published a report called Labor Market Impacts of AI, a New Measure and Early Evidence. And it introduced something they called observed exposure, which is basically a metric that puts theoretical AI capability next to real-world usage data to see which jobs are actually being impacted, to try and get away a little bit from the hype and the media cycles. And the report is summarized well with the radar chart. So if you can picture those, almost a circular chart, and it looks like there's a spider's web in the middle of it. They used to use them at school to rate how good I was at different skills around cooking in cooking class. And essentially what you see in this image is a large blue spider diagram that stretches out towards the edges for a bunch of different occupations of management, business, computer, architecture, life sciences, social services, legal, and that's a theoretical impact of AI on these occupations. And I can tell you, it's a much, much bigger spider web than the red one, which is the actual current observed usage. And this is measured by Anthropic's own data. And the numbers are really interesting between how much AI could theoretically transform these occupations versus observed usage. Like computer and maths, 94% theoretical, but only 33% observed. Legal, nearly 90% theoretical, but barely past 20% observed. Almost across every domain, it's the same pattern, apart from a bunch of domains that basically hasn't been impacted at all. You've got grounds maintenance, food serving, agriculture, construction, installation and repair. None of those have been touched by AI, really. Obviously, Anthropic's interpretation is that this is a major growth story. They said, and I quote, "As capabilities advance, adoption spreads, and deployment deepens, the red area will grow to cover the blue area." And in their framing, the red is the blue's younger self. Give it time and convergence is obviously inevitable. However, you could read it differently. That gap could also be telling us where the boundaries are, not where it's heading. And Anthropic is looking at that distance and seeing potential, whereas, as we know, some people will see it as a big chasm that may or may not ever be crossed. So yeah, let's discuss that. So from one perspective, you could argue that the ceiling is actually lower than it looks. So that blue shape, that theoretical ceiling, comes from a 2023 OpenAI paper called GPTs are GPTs. It's almost 3 years old now. The authors went through every task in the ONET database, which is a primary source or US source of occupational information, covering about 900 jobs. And in the study, OpenAI scored each one 1 if an LLM alone could double the speed, 0.5 if it could with additional tools, 0 if it was out of reach. Anthropic adopted this as the upper bound of their chart. The issue is how those scores were generated though. In the study, they were asking whether a task could be sped up by a model with, say, a 2,000 word input limit and no access to current information on the internet. That's not measuring what happens when the AI has to be integrated into a complex procurement workflow at a bank. It's not measuring what happens when the output has to pass a legal review, or when the data lives in 3-4 different systems that just don't talk to each other, or when the person using it doesn't trust it. It's measuring what's possible in a very clean, very controlled, hypothetical environment and then try to project that across the entire economy of that occupation. And Anthropic does flag this, to be fair to them. But their argument is that the models just have improved. So the real ceiling is probably much higher than the blue suggests. But you can run that logic in the opposite direction too. The original scoring was probably way, way, way generous because it was measuring what a model could do under perfect conditions with no friction, no context, no complexity, and also during a period when hype around LLMs was at its absolute peak. So if anything, you could argue the blue is too big, not too small. See, I think studies like this are really helpful to understand, but not obviously where I get very interested, which we'll come on to, I guess, in the secondary part of this discussion. Because I've talked a lot about this. Benchmarks these days are, well, just as much about the importance of vibes, so the vibes of this new LLM and how it feels, and B, the complexity of real-world deployment. That's what these benchmarks rarely capture. So the question I'm actually interested in is, how do we make this translate into a situation where conditions aren't perfect? Because these benchmarks are all in perfect conditions. The chart suggests that the answer is not nearly as simple as we'd like to think, because that red spider's web is much, much smaller than the blue theoretical one. Let's explore that. Why isn't AI impacting more tasks? I want to say something quite clearly before we get into this discussion, because it could sound like I feel somewhat negative about the situation where that's not actually where I land. I would describe myself as a realist's argument about the situation, because I believe AI is going to be transformative. I work in the industry. We actively build systems and products to deploy it into big companies. So yeah, it's more of a realistic argument about how long transformation actually takes before technology becomes truly at scale. Anyway, there are a few things to explain this gap, I think, in theoretical expectation and reality. One is about the technology, which something we as in Mindset are actively working on. So it's really interesting and can really give a kind of insider's perspective on. And the others are human problems. And I think really the human and organizational problems are the hardest to fix. Let's start with the people problem. The first problem is that the adoption curve is more of a cliff rather than a slope right now in AI. OpenAI's own numbers tell us a really good story. ChatGPT has about 900 million active users or weekly active users, less now after the Quit GPT movement. And about 50 million of those are actually paying. Power users, so the top 5% of those paid subscribers, use reasoning capabilities about 7 times more than a median paying customer. So if we do the maths on that, 5% of 50 million is 2.5 million. That's 0.25% of the total user base actually using AI in a way that could truly reach that theoretical expectation of how AI will impact an occupation. Most people, therefore, we can assume, are using it for very basic things or in a way that isn't going to transform their occupation. If this were a normal adoption curve, so in technology, when a new technology appears, we see something called an S-curve. So it's a standard model for how new technologies get adopted. It looks like a flattened S on its side, which means a slow uptake at the start, early adopters with small numbers, then a steep acceleration in the middle as mainstream users pile in, which is called the tipping point. And then it kind of flattens out at the top as you hit saturation, and only really the laggards are left to start using it. Well, if we're experiencing that, the middle should be filling by now. And you could argue that it is, and that when you're in the middle of it, you are very impatient. But 3.5 years after ChatGPT launch, and it isn't. What we're looking at is close to a cliff edge right now, a tiny spike of heavy users right at the top, and then the near vertical drop to everyone else. So a handful of people have obviously figured it out, and a vast majority of people have just bounced off or haven't found the use case or skill set to make it stick. And I'll say this because the data seemingly points to it. I think probably we have a skill issue. Now, it could be me being impatient here, and therefore that cliff will become that S-curve over time, and it's just going to take a little bit longer. We'll have to see. But I don't think most people have developed the ability to use these tools in ways that produce seriously meaningful results. And nobody is teaching them how to do this at scale. I bet it's not being taught at school. The second problem is that the economy moves far slower than, I guess, the AI industry wants to admit. So large companies don't rip out enterprise systems they're running on because something better came along. They're locked into 12, 18, 2-year contracts with platforms that, meet their needs quite well. Even if those platforms aren't AI native and aren't that impressive, people will be forced into waiting. Now, that won't last for long. At the end of that contract, they'll be at risk of losing, or they'll be forced to start integrating other companies into that solution, which will slowly eat and eat and eat away at, I guess, the perceived value of the big company. So the cycle time for these enterprise software deployments are measured in years. Some companies take 12, 18 months to deploy a technology. So therefore, there will be a slow adoption at enterprise level. Even if they've all adopted ChatGPT, there's still tens of thousands of other SaaS or technology platforms who are solving problems and who are not AI native. And, only 3% of Microsoft 365's 450 million users have even adopted or opted into Copilot yet. So again, it will take time. The third is that the technology stack is actually harder to integrate into apps people use daily. And so I see it as also a supply problem. So what I mean here is that you see the supply side every single day. So people might use AI if it was in front of them in a technology solution they already use every day, but it's not. So they therefore would have to learn to be an expert on other AI native tools. So the Claudes, the ChatGPTs, the many, many others. Because we work with technology companies, SaaS companies, typically large B2B SaaS companies deploying agents into their products. And the complexity is really, quite staggering when you go from, say, a prototype or a quick demo. You need an entire stack to make all of this work. You got huge amounts of complexity to embed and integrate these into solutions. You need to identify how it's all going to work and even the use cases that you want to deploy for first. You need an agent framework. You need reasoning and logic. You need to wire this into all your systems. You need to understand how agents understand data and APIs. You need to build APIs for that. You need to create MCPs. You need to create a tool calling layer. You need to then have a testing layer. You need to be able to surface the right information and test that that's the right information, because big enterprise companies really care about compliance. You need a purpose-built interface for every type of interaction, like widgets appearing in chats and charts. All this has to then work at production scale, not just for, 2,000 people or 100 people. And I'd say that about 75% of the companies we talk to are either just getting started or a little bit into a build. And these platforms aren't small. They're, companies with 10, 15, 20,000 enterprise customers worldwide. And so without that supply, i.e. the big companies that already have millions of users, integrating this into their products in a really effective way, it's really hard for most people to use AI. So the real question, therefore, is will it grow? And I'm confident that it will. And I think there's a really core component to what will make it grow. And that's making the technology itself reliable. So this comes to the fourth reason that I think that there's still a gap between theoretical and real world usage. And this is most interesting to me because it's what we're obsessed with trying to solve right now. It's, something that we actively are always in at Mindset. So essentially there was a really good paper that highlights this point and discussion here. And it's called Towards a Science of AI Agent Reliability. And it essentially puts rigor behind something, I've been saying on this podcast for a long time, that the industry is often measuring the wrong thing. You draw a line between capability, so can a model do this task, and reliability. Will it do it consistently, safely, and predictably in conditions that are rarely perfect? And we don't just mean that they do the right thing most of the time. We mean something much more, and this is what the paper breaks down really interestingly. A colleague, and therefore an AI agent, must be able to, number one, be consistent. This means they get it right consistently, and that means not right today and therefore wrong tomorrow on the same task. Number two, robustness. They can't just fall apart as soon as conditions aren't perfect for them. Number three, calibration. They're able to tell you when they're unsure rather than confidently guessing. And number four is safety. So when they do make a mistake, their mistakes are fixable and they're not just catastrophic failures. Again, what you'd expect from a colleague. And to assess agent reliability right now, the authors broke down all of this into 12 metrics across 4 dimensions and tested 14 different models from OpenAI, Google, Anthropic, spanning a year and a half of product releases. They ran each task 5 times with different sets of paraphrased instructions. And they also deliberately broke things. So they tried to cause tool failures and API calling failures. They tried to simulate environmental faults to see how agents handled imperfect conditions. they asked the models to report their own confidence to test whether they could tell when they're wrong. Overall, they had 500 total benchmark runs. And the headline finding was that 18 months of LLM capability gains produced only modest improvements in reliability. All three major providers clustered quite closely together, suggesting that this is an industry-wide challenge, not a company-specific one. And for me, I don't think this is solved at the model layer, it's solved at the application layer. So for example, on consistency, whether the model gave the same answer when asked the same thing twice, scores range from 30 to 75%. On robustness, so whether it can deal with imperfect conditions, models handled infrastructure failures like big server crashes quite well, but apart from that, didn't really do that well. On predictability, whether the model knew it's wrong, performance was also very mixed. And this speaks to a challenge within implementing AI right now, I think, that, Mindset sees all the time. It's something that we're actively working through. And as I said, it doesn't get solved at the model layer. It gets solved at the application layer. And again, models are trying to bring in more application layer technologies. So they're trying to turn their model into an agent itself in the way it works. And this also is why SaaS companies have such a big opportunity really to create perfect agents for their specific niche. Because a general purpose Claude, although it's absolutely incredible and can do many things, if you make a hyper-specific agent for a specific area that you're an expert in, can be really, really powerful and more consistent, more robust. And the reason that we have to deal with this is essentially what you're asking is, do we want an agent to have deterministic controls or have high inference? So essentially, can an agent decide and reason what to do? High inference. Or do we as, say, the agent creator, give it specific instructions that it's not really allowed to stray from? So if you give that agent a step-by-step plan to follow, that's all it can ever do. So if a person comes in and wants to go in any other direction, it's not going to be able to do it. Or if you let it reason itself and decide, it might go off in different directions to solve the exact same problem. Because ultimately, an agent, all it's doing is observing, planning, acting, checking, adjusting. So it makes a plan, it sees how that plan goes, sees what data and information it gets from that plan, checks whether that's the right thing, and if it isn't, adjust or check in with a human. So that's what enables agents to do really incredible things that blow your mind. And it will deal with imperfect conditions really well. It can tell you when it needs help. So it can act more like a person, but it doesn't mean it's reliable. There's loads of different things that can go wrong when it's reasoning. So this is where that trade-off between consistency and flexibility becomes really important. Too rigid a set of instructions, it can't help people in any ways other than that step-by-step plan. Too much inference means that it's likely to be inconsistent. And so there's lots of ways to try and solve this. Mindset solving this in really interesting ways. We're creating something called blueprints, which is more like giving an agent a set of DNA, which is a set of instructions that can last over many months. So rather than just, a quick process, you can give it the ability to solve, say, 50 problems with what we call tools. Now, a tool might be, a integration to a separate system to help a user do something. It could be a small set of instructions that the agent can follow. But a blueprint is essentially its DNA over many, many, many months, like a long-term objective. It might be for HR and recruitment, an entire employee life cycle of how it expects to help people. Or a product discovery journey that might take 6 months. So it describes a set of things that an agent must take people through over a long period of time. So yeah, this is a really big area of investment by all these big companies. It's really, really important to solve. And all of it does take time, and therefore it takes time for adoption. And we've seen this before. In 1987, there was a writer that said, "See the computer age everywhere but in the productivity statistics." And in February, Apollo's chief economist said the exact same thing about AI. So yeah, 15 years into the computer revolution, productivity actually slowed, especially during the IT build-out. It dropped from 2.9% annual growth in productivity to 1.1%. But then between 1995 and 2005, it surged. The technology hadn't necessarily improved that much. The change was that organizations finally rebuilt how they worked with it. The technology was super consistent, it was accessible, and it took a decade and a half to do. Let's conclude. The dominant narrative, I think, says that there's a massive market disruption that's imminent, and I think we're starting to see that. Dario Amodei, the CEO of Anthropic, has said this over and over again. But clearly the story I think this data supports is a little bit more complicated. AI's economic impact is definitely real, but held back by reliability limits that the industry hasn't yet fully solved, and organizational human barriers that are just not easy to solve, because theoretical baselines are always more aspirational than measurement. So yeah, will AI transform work? Yes. Computers did reshape the economy, but on their own schedule, not on what the industry wanted it to be. And because everything surrounding the technology had to mature with it. And I think the same thing is happening right now. And this type of reliability research is going to force us all in the industry to measure what matters. So anyway, I hope you enjoyed the episode. I hope you learned something. Thank you for listening, and I'll see you next week.